And welcome to the Advanced R Book Club with the Data Science Learning Community. Martin, go ahead and take it away.
Well, thank you, John. Thank you very much. Well, today is the big day. We're going to be learning about metaprogramming, and specifically, I take the metaprogramming intro, and the chapter that is also like an intro is like a summary about a bunch of concepts related to metaprogramming. And I'm actually really excited to be presenting this because this is the reason why I entered this book club in the first place. And also, I'm not really used to speaking English, so I will try my best. It's a good practice, but let's go on. So some learning objectives. Well, before we had like two main learning objectives, like from the past cohort, was like basically knowing a bunch of new concepts related to metaprogramming, and now we have like more specific learning objectives, like capturing code as data using expression. We're going to be inspecting code like trees. We're going to be generating and executing code programmatically. Also, we are going to be using data frames as execution environments and recognizing why closures, that is a funny word, are basically useful. And we're going to be using two main libraries, the Erlang library and the Lustre library, mainly Erlang. And it's funny because this part of the book has like these chapters that is the big picture, but before has like an introduction. So I'm going to emphasize some general ideas about metaprogramming that comes from this introduction. First, like a general definition of metaprogramming, that code is data and that can be inspect and modified programmatically. And also, Hadley like give us some quick examples in this introduction section about what we can do with metaprogramming or what metaprogramming allow us to do. Uh, for example, metaprogramming is the thing that allow us to write library per instead of library per, like with quotes. And also, he talked a little bit about non-standard evaluation, like NSE. And here I tried like to give an informal definition about how I understand non-standard evaluation. And basically, non-standard evaluation allow us to write functions that behave differently than base R. And in my mind, it's basically not telling R where an objects come from. And here I put two examples. One we're calling a vector, and in like a standard way, we are telling R that we want to be checking the seal vector that comes from empty cars object. But also we have like the non-standard version from base R, like calling only seal from empty cars using the with function, and also calling seal via pull via declare package using tidyverse. And I have like another example of that. But the whole thing is that we can, like with non-standard evaluation, we can call seal, not telling directly to R that seals come from empty cars. At least that is my understanding in a more practical way of looking at.
Yeah, I think like in general, it's you could try to say, well, in R, you can't reference the column from within a data frame. You can only reference things that are declared in the active environment. And then non-standard
Yeah.
evaluation is when you go, well, that's not really true. Like we can make it
Yeah.
work. So
Yeah. Actually, that is a
breaking the
good,
rules.
yeah, breaking rules like that.
Wasn't it said in the book that this like applies more to like what you do to arguments and functions?
Yeah,
Yeah.
exactly. Actually, Hadley say this that usually non-standard evaluation is commonly used to describe behavior of R function, but not this is not accurate. That NSE is a property of the argument, not the function itself. So yeah.
Mhm.
And second, I think Hadley doesn't like this concept because he says like it's kind of confusing to define something by what is not. So yeah, so what is a standard and what is not standard. So who gives the idea of standard anyways. And yeah, actually, this whole part of the book, the metaprogramming part, he wants to give us more clear concepts to be thinking about metaprogramming and to be learning about metaprogramming. And across the book, he used the word tidy evaluation. That is the the Erlang version of NSE. And he says that we're going to be using tidy evaluation from the Erlang package that I think is a package that the tidyverse team created for doing tidyverse stuff, like programming in tidyverse styles. And according to Hadley, this will allow us to focus on the big ideas without being distracted by the quirks of implementation that arise from our history. And I think that is important because you can also do metaprogramming with R-based function, but Hadley like to use and probably recommend to use Erlang for doing this. And yeah, that was like the ideas I wanted to emphasize about the introduction part. Now let's go with the big picture chapter. And it's quite convenient that this chapter have like 7 sections, and those 7 sections are like the 7 big ideas uh, that you can emphasize about metaprogramming. So we're going to be covering each of one of these big ideas. Personally, I think the first 4 are the most important, but we're going to be talking about this. So let's go with the first big idea, maybe the core about metaprogramming, that basically code is data. And more specifically, code is captured as data in what we call expressions. So basically, we're creating an expression when we are capturing code. And captured code can be a call, can be a symbol, can be a constant, or can be a pair list. These are some details that we're going to be seeing in the next chapters, I think. So in this presentation, I will be talking or using like the general concept of expression. And I borrow a quote from Hadley from the next chapter when he says that we are separating our description of the action from the action itself. And I think it's really useful because we are like thinking I like to think in a cooking analogy. Like on the one hand, we have the receipt from doing a dish, and in the other hand, we have like the dish or actually making a dish. So when we are capturing code, we are like capturing the receipt of the dish. And for capturing code, we have, at least that is my understanding. It's really useful for me, that cooking analogy. Maybe we can discuss some of that later. But for capturing code, we have like 2 main ways, depending on the context. First, we have like the expr function. I'm going to call this expr from the Erlang package to capture some code directly. So everything that we put inside of this parentheses, we're going to capture it. So the output of this function is basically the function that we capture. And if we want to do this like indirectly, we are going to be using an expr that we use it when we want to capture like an user's input. For example, when we are creating a function. And in this example, we are creating a function named capture it that is basically doing the same that expr are doing, like capturing some code. I don't know if there are some. Okay. Another important idea is that capture code is like a list, and actually you can inspect this code like a list. So here in this example, we are capturing this f function, like with the x argument and the y argument. And if we check the names of this expression, we can see that actually, well, we don't have a name for this first element, but the first element is the function. And the second element is the first argument, and the third element of this list is the second argument of the function. So it's really good to know that we can think expression like they were a list. And the fun thing about this is that we can modify this expression like they were list. So here I'm capturing again this code with an F. And then I'm creating two copies like FFF and FF, and modifying these copies. To the FF copy, I'm creating a new argument, and to the FFF copy, I'm removing an argument. And if we take a look, we're going to see that the first capture expression, like the original one, is not, we didn't do anything to the expression. But the second copy, we can see the argument that we insert. And if we see the third copy, we can no longer see the argument that was there before, but now not anymore. We remove the X argument of this expression. So yeah, I think that is the most important thing about the core, about the idea that code is data. So let's go with the second idea, that code is a tree or can be represented as a tree. And I think the like technical definition or technical concept of this is abstract syntax tree. And accordingly to the book, almost every language represents code as a tree. And at least in R, we can inspect these code trees with AST function from the Lofter package. And here are some examples from the book. For example, we have the F1 function that is calling the F2 function and also is calling the F3 function. And we can see that all of this like call is going to be represented as a tree. Like actually, this is a nested function, so it's like a nested tree. And we can do this also with the infix function. For example, mathematical operators, and we're going to see the same thing. Like we can check this expression like it was a tree. And here I added another like examples. I like to be concrete with some examples. So I added this with the min function to show that AST can have different shapes. For example, here creating a dummy vector that goes from 1 to 100, and I'm inspecting the code tree of this function min, and we can check the simple tree here. And if we add some arguments to this min function, min call, we're going to see that is represented in the tree. And actually, if we do some nested function, for example, we nest the min function inside the round function, we also can see this like a tree. And I don't know if this has some like practical implication, but I think it's one of those things that is really good to know. Like what is doing R under the hood, like every code can be represented as a tree. Like that is maybe the conclusion here. The third big idea is that code can generate code, and here we have like two or really three main tools for generating code from code. The first two that are in this book are the call to function, that I think is like a remastered version of the call function from base R. And also we have the bang bang operator, or also known as unquote operator. And we have this third main tool that is called the embrace operator, or curly, I think. That is really useful when we want to use the bang bang operator with a function named encool that we're going to see later in this presentation. And it will not be like getting deeper on this operator. Maybe we're going to see it more in the next chapters, but at least in my experience, it's really useful when we are writing code like creating function using tidyverse functions. Like it's the simpler way of doing that, and it's more elegant. I don't know, at least in my opinion, like rather than using this bang bang and cool
Mm.
uh all the moment, all the time.
And it's call to like do that call.
Uh, yeah, our culture are is like call, but actually I don't know the differences between these two. I don't know if John, you know the.
Yeah, he goes into it a little bit. Um, like it has some different rules of how the things are constructed. Um, I don't remember what the arguments are in call itself, but uh, yeah, you can specify a
Okay,
namespace where you're like where it lives, different things like that. But um, it's just like a lot of things in our lang are let's take this thing that is in base, but the arguments are in the wrong order, or it's not as strict as we'd like it to be, or it's more strict than we'd like it to be. Just things to kind of make it all more standard as far as how they like to program things. And like, I agree with them for the most part. Um, so this is definitely an example of that where it's just kind of a refined version of call.
yeah. Actually, I think that that happens a lot with Erlang, that we have like function two, like
Yeah.
I don't know,
List two.
list two. Yeah, yeah,
Yeah.
that is a good example. Yeah. So let's go with the call two.
So map
Uh,
2 is also similar. Map 2.
no, map two follows other way. It's
Rules.
like
Yeah.
yeah, other rules. Yeah, yeah. It's like in another context.
Yeah. I think all of the Erlang twos are like the sequel. It's the sequel to
Yeah,
call. And map two is specifically saying that there are two arguments. So
yeah,
Got it.
it's
exactly.
a different,
Got it.
yeah.
I see the difference. Okay, thank you.
Mm. Yeah, thank you, John. So call two. Call two constructs function calls basically, and that's mean building a function from its components. And this means like separating the function to call and the arguments to call it with. And in this simple example, we are calling an f function and we're calling the arguments like 1, 2, and 3. And it's fun because the output of this call is the call in the way that probably we were writing in a normal, I don't know, in a normal way, in a regular way. Um, and also we can going backward, like from the tree, we can start to build some calls. So for example, here we are calling the f2 function and the f3 function, and those calls are inside a call of from the f1 function. And we can do this also with infixed function, like the mathematical operators. And here we're doing the same thing, the same thing. We can construct like this operation by via call to. And here I think, yeah, I put also an example with the min and the round function to show that basically call2 can build complex call. So here I'll also create that dummy vector, and then I create a call of the min, and I put the arguments of the call that I want to do, and the output of this is going to be like that recipe or that instruction, that piece of code captured showing that uh, min is calling this dummy vector and is trimming it and is removing the NAs. And that we can do here. I'm showing also that we can do this with nested functions. So here again, I'm nesting this min call inside a round call.
It seems like
So Mhm.
This is really cool because I can see like if you like, for example, if you start up in a Shiny app and there's like a bunch of things that you want to call the same way in different places throughout the app, you can use call to like loop through like 50 different things you want to call in that order, in different places. And the output's an expression, right? So you can evaluate it with
Yeah.
environment you want or different ones. I think it seems cool, but like at that point, like why wouldn't you write just a function that does all that? It's cool that you had different ways to do it.
Yeah, like constructing a call from scratch like this, I can't think of any time I've ever done it, but I've done some of the things where you like edit, capture the expression and then edit it. Um,
Mhm.
Mostly I did that at one time because there was something in a package that it had just had one little piece of behavior that annoyed me. And so I would like use the package but edit it on the fly when I did the call. Um, I think there are much more elegant ways to do what I was trying to do, but whatever, it worked.
I think it's cool, like if you had like a collection of functions that had like a similar like people they prefix the functions or whatever. Like if you had like a if you grabbed for like a dozen or whatever functions from a namespace or whatever it is, like you can without even knowing a priori what they were, just knowing like the prefix or whatever it was, you could like you see, okay, here's what this collection function does with this same output or this same input. Because I
Mhm.
could see it like being useful in those cases. So it's just really cool that this is available.
Yeah, I think it's like it gives the developer or the our user a lot of I don't know, flexibility or freedom to be doing a lot of things like in different ways.
And is this
I
anywhere
just
else? Other language, like, I don't think Python has this.
I don't know actually.
I'm not sure. I know that R is weird in the way that like everything is data, everything is an object, and you can like mess around with things. I think a lot of languages you can do this. It's just not as
Mhm.
um simple to
Easy.
do it.
Mhm.
Um, and there aren't such key examples, being the tidyverse is built around this stuff. And so because of that, um, there's good code to look at that implements these crazy things. Um,
Do
I
you
did see one main difference between call and call to is call strictly needs a string for the first argument, and call to will let you say, you can just put mean without quotes because you can just send it the function. I
Mm.
think you can send it like per style formulas. Um, Anything that it can figure out, it is a function
Mm.
it'll take.
Very cool.
Yeah, these are cool. Are cool. I really like that the Tidyverse team like shares the package with they that they using to use Tidyverse, like to create Tidyverse, basically.
Yeah. Yeah.
Yeah, I really like that. So let's go with the second way of generating code with code. And these are the bang bang operator, or the unquote operator. And it's funny because I think this is, I don't know, at least it take a while for me to internalize this behavior, but the example is really simple and it's really like showing what it should show. Here we are, well, the injector operator inserts previously defined expressions into the current one. And here in the example, we are creating two expressions like XX and YY, and we want to build another expression with that previously defined expression. And the thing here is, if we say to R that, hey, we want to do an expression with XX and YY, R is going to think that we actually want to use this like XX, the name of the value and not the value itself. So to say to R that we want to use the value itself, we must use the unquote operator, and then everything is going to be nice. Like, hey, I don't want to use XX. Actually, I want to use what XX represents, and that is X plus X. I don't know if there is another way to explain it, but yeah, it's a really good example, I think. And
It's
also, yeah,
it's crazy to me because it doesn't like exist. Like it's not a function, it's not an operator, really. It is that the Erlang code sees it and does things. Like inside of the functions, they interpret the bang, 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 like as text. They go, oh, okay, I need to do this
Mm,
thing. Um, but it looks like, or as far as R can see, it's valid code because it's just not. And so R's like, oh, okay, yeah, you can say that. I don't care. I'm not going to error on that. Um, so it's a like clever little fiction that they use to
yeah.
just make it go through. Um, and when I was learning it, the like way I thought of it is you don't want to use XX, so it's not XX, but it's also
Yeah.
not XX because it's kind of you're using XX, so it's not XX.
Hmm.
Yeah. Yeah, it's
Anyway,
I don't know, I think it's a good solution for
yeah,
like for solving these cases where we want to you combine some expressions. And actually here we have like a function example where we want to create like we want to create like a function that give us the mathematical formula of coefficient of variation with the user's expression, with the user's input. If we want to do that, we can capture the user's input from the bar argument with nexpr, and then use it when we create another expression with the SD and min functions, and using the unquote operator. So using the unquote operator here is going to allow us that the results of this function is actually like the formula of the coefficient of variation with the user's input. In this case, x, or in this case, x plus y. And I put another example those, uh, without those, without the operator. And here we can see that if we don't use the bang bang operator, basically we're going to have always the same results because R is going to think that we want to build the expression with the name of the argument. And in this case, the name of the argument is bar. So uh, regardless of what we would put here, we're going to be having from result this SD bar slash min bar always. So basically it doesn't work.
So John, F. So what you put in the chat, F. So what is Bang Bang then?
it's a thing that Erlang functions interpret under the hood. Like they see that it is there and
Uh,
interpret it. Most of the functions now are um, C or C++, I think, under the hood. And so I haven't gone all the way down in to see exactly what they do to see it, but it's not interpreted inside of R.
that's so interesting.
Um,
So only within the Erlang functions does it like know how to interpret Bang Bang.
yeah. And so
Mm.
then like when they use this for if it happens somewhere where it's not supposed to happen, they treat it as a function and
Mm.
you know do that basically. So
Yeah, cool.
it's
Thanks.
tricky.
I think the the Erlang documentation have something like what if you use bang bang or another like Erlang functions in a context that is not Erlang. I think they have something like that.
The
So,
closest
yeah,
I
John.
can think of it, Nicholas, is me coming from SAS world where we have an ampersand. When you have an ampersand or percentage let, that captures the value rather than the string itself.
Oh,
Yeah.
that's
So when you have an ampersand with quotes and quotes that puts the value rather than the string. So the bang bang will tell the expression that okay, use the value instead of this thing. So because it is dynamically changing with the user input, the user input can change, right? The var value can change as per it is. So when the var changes, use that value instead of actual keeping it static.
okay. So yeah,
Mm.
that's a special thing.
Yeah,
Keyword, yeah,
I
we
think
can
it's
say it as a keyword or system way of recognizing or the telling R, okay, this is the way it is. And we do have something, those kind of specific words for the language specific.
Okay, got it. Thank you.
that's good to know.
Yeah.
So, yeah, here there is a warning from Hadley that we should avoid using paste for building code because may have problems with non-syntactic names and precedence among expression. And he says that you might think this is a not necessary concern, but uh, it seems like these have some real consequences in real life. So, in general, not a good idea to use strings to building code. So, okay, let's go to the fourth main idea, I think, that evaluation runs code, and actually evaluation runs code in an environment. And I don't know, bringing back my analogy, my cooking analogy, this will be the moment that we're actually making the dish following the instructions. And basically, evaluation means running or executing an expression. And for doing that, we need both the expression and the environment. And for now, we are going to be using eval. There is our base function that you can specify a particular environment. And if it's not set, it's going to use the current environment. And the fun thing about this is that when you're doing manual evaluations, you can actually tweak the environment. So in this example, we are capturing the expression x plus y, and then we are evaluating this expression in two different environments. In the first environment, x means 1 and y means 10. So when we evaluate this, it's going to give us the result of 11. But if we change the environment that we are using, it's going to give another result. In this case, 102. And here we start with like some more detailed stuff that we can customize evaluation with different things. And the first one is that we can customize evaluations with functions. We actually can bind names to functions in a supply environment, and even we can override some function behavior. So in this example from the book, Hadley is creating like a new function to do some math with strings, like operation with strings. And to do that, he's creating a supreme or alternative environment where he is like overriding the behavior of the plus sign and the multiplication sign to work with strings. And then he is capturing the expression given by the user and then evaluating that expression in the environment that he previously created. So when we use this function, we're going to be able to do like operations with string. So here we're doing like a sum operation, like hello plus cohort plus the cohort number. And this will give us the result of hello cohort 10. And if we do this with the multiplication sign, we also can, it's going to work basically, because we're summing up these strings, DSLC plus is plus awesome. And this will appear 10 times because it's the name of, it's the number of our cohort. And I think this is really fun. I think this gives us a lot of flexibility, and it's good that we can do this in a different environment, because probably it's not a good idea to override the plus sign and the multiplication sign in our global environment. So yeah, it gives us some flexibility to do some fun stuff. And also,
Just a quick question on that. So you said the
yeah, sure.
caller environment, right? So that's a environment where we can rewrite the basic rules of it. Say, for example, the plus means adding two of them, right? Can we make the plus to do a multiplication thing with the caller environment, this thing?
That you can do
Yeah.
whatever you want. You're redefining that function.
Wow.
So yeah,
Yeah.
plus is a function, and so you're defining what plus means. You're overwriting it basically within that environment, but it only changes it like in that environment.
Exactly.
Okay, and if there's a conflict between the other global and this one, so which one would take the precedence?
It always takes the most specific for where it is. And so in that case, it would take this one.
Everything this. Okay, I see that. Good to know. I mean, very strange, but good to know.
Yeah, it's fun because I think R is a language that allow us to do some weird things that you shouldn't do, but like overriding base function with whatever you want to use. But yeah, this is an example that you can do it safely, I think.
Well, and like it's that you don't have to know every function. Like you can, using plus and star makes it look really weird. But I mean, I'll bet all of you have used df as a variable, and that's a function in base R that you overwrite all the time.
Oh, that makes sense. I didn't know that.
Yeah, or filter in dplyr is when you library dplyr, you're overwriting the stats version of filter.
I thought DF means data frame all these days. Okay, I didn't knew that. It was
yeah, it's like it to most people it does, but it also means the F distribution. So and it's really funny because within the DF function, DF1 and DF2 are degrees of freedom 1 and degrees of freedom 2. And so no one you can do that.
Wow.
And you can actually have like R when it sees parentheses, it says, I have to look that up as a function. And so you can have a variable with a name and a function with the same name, and it would choose between the two. I don't advise doing this on purpose, but the point is that you can set things up for situations where it makes sense. And yeah, you can do the prefer conflicted package to set kind of who wins. I think so. Towards the end of the book, when we're doing there's a thing where we're writing a I can't remember the name of the term, but we'll see a lot of this where it makes sense. DSL, domain specific language, where he started to set this up I could see setting up a whole bunch of shorthand for string manipulation while you're working with strings, just to make your code easier to read in context. But you're doing that all inside of this environment so that it only impacts the stuff you're working with. Anyway, I'll let you continue.
Nice, thank you. So let's go with the next possible customization of evaluations. And this is that we can customize evaluations with data. And this means like looking for variables inside a data frame. So instead of using an environment, we actually can use a data frame. And this is related to the concept of data masking, or also an R-lang concept that take a time for me to internalize. But I think it's basically that you are evaluating things first in a data frame and then in another environment or in the next environment. And here we have like a simple example where we are using now eval tidy rather than eval for doing this. And in this example, we are creating a data frame like x goes from 1 to 5, and we're creating a random sample of 5 numbers in y. And then we are summing up x and y inside this data frame. And it's going to be doing this operation or doing this evaluation with the columns that we have in this data frame. And also we can do this like in an indirect way, like if we want to catch some users' input. And until now, we have done this with the nexpr function. And this will be, this can work here, but there's going to be a bug. So here we're like recreating the with function, the base R with function that evaluate expressions in data frames. And we're doing that with eval tidy and nexpr. But the bug is that if we use nexpr, it's going to evaluate first the environment of the function, in this case of the with2 function, but the expression probably refers to objects in the global environment. So I put some comments on this example. Here, when we are creating with2 function, we are like creating also an A object that is 1,000. And then we are evaluating the user's input with the data frame also from the user. And this is like the moment when we are using the function. Let's imagine that we have like a data frame and we create an object A that is a 10. And we want to do some math with that A with the data frame. This is not going to work because R is going to take the A object from the environment of the function instead of the current environment, in this case, maybe the global environment of the user. So for solving this bug, we have our new friend, Cohort, that basically Cohort bundle an expression with an environment. And the function that we have for doing this is enqueue. This captures a Cohort or creates a Cohort. And the important thing here is that they bundle the environment where the expression is created. And so basically, when we are using, when we want to evaluate some things on a data frame, we must use enqueue instead of nexpr with eval tidy. So if we replicate the example that we were looking before, we also can create an A inside the environment of the function. We evaluate the capture expression, and then we are like using our new function, creating a data frame, creating the object A. But here is going to work. Basically, because this enqueue recognize that this expression comes with an environment where A means 10. Instead of using this environment, is using the current environment. And Hadley say that whenever you use a data mass, you must always use enqueue instead of nexpr. And we have like a more technical declaration here that Cohort bundle the environment where the expression is creating, or in detail, the parent of where enqueue is called. And I think here we have like a couple of slides. I think these were made by the past cohort. I saw the video of these presentations from the past work, and they were like experimenting of hey, which environment is bundling with the expression that InQA is capturing. So there are here like a more detailed demonstration, but the main idea is that what I already said, that closures bundle the expression with the environment where the expression is created. And here I have like a quick summary from all the things that I already presented. Some big ideas of metaprogramming in R. We can capture code as expressions with rlang expr or an expr. We can represent code as a tree and inspect it with AST function. Also, we can create calls from function components with call2. Also, we can inject previously defined expressions into an expression with the bang bang operator. And when we want to make the dish, we can evaluate expression with eval or eval tidy. And some more detailed stuff that we can use expression to customize evaluation. For example, overriding common functions with evaluation environments. We see that with example of the plus and the multiplication sign. Also, that data mass are data frames used as evaluation environments. And we have our friend Cohort that captures both the expressions and the environments in which it was created. And for doing that, we have the include function that captures the user input in a Cohort. And I think that's it. Thank you for your attention. I'm glad to hear some thoughts on this. Yeah.
It amuses me that this is just an overview. We're not really going to get into the meat of metaprogramming yet, and then there's so much in this chapter.
Yeah.
So like we're going to see a lot more about each of these pieces in the upcoming chapters, but he goes into quite a bit about like the concepts, and there are definitely situations where this stuff is really useful. It's this is definitely advanced R. Like you're not going to use this in everyday coding. Although if you do any like using tidyverse functions inside of functions, it's good to know this stuff. That's where the embrace operator stuff comes in a lot.
Well, stuff that in my context, what I do is that I posted this in the chat. So a number of times I have to work off metadata where I would have some code that is provided externally in some Excel file that says, well, this is the variable that I have, and this is how that comes in the raw data, and this is how it's supposed to be cleaned or recoded or processed in some other way. So I would need to capture the name of that variable, which is the cell in Excel. I would need to figure out, well, this is the data frame that it applies to, and this is the code that needs to be run. So I glue this, paste, zero this with some mutate verbs and whatnot, and that's where this sort of NSC comes into action in my workflows.
Actually, I think I have like a similar experience. I work a lot with survey data and I process a lot of survey data. We do validation rules and all of that kind of stuff. And usually we have like a bunch of validation rules that they are R expressions in an Excel, and we use that Excel as an input to program with. So basically we are treating like pieces of code. But yeah, I think that the most common usage of this is like wrapping tidyverse function.
Right, that's what the tidyverse team wrote this for, but well, that obviously other users as well.
One thing that I use a lot of Rlang for, and it kind of gave me a headache a little bit. But I think it still is, but I don't know. I gotta look at it. But I use a lot of targets, and I'm using arrow a lot. And because there's nothing interactive about it, I had to capture variable names and stuff from a YAML file. And so I had to give everything from that just a YAML file. And I want to like use arrow, not load in the data all at once. So I have to like use the inject like at the triple bang and then laying which one that's sim something and then I thing in there. It's been working pretty well, and I also noticed I have to put that within a function call and not in the actual targets file, or else like it doesn't know how to interpret. So it's and that's like more layers of things that metaprogramming comes into play.
Mm. Nice.
Quick question, thought process is there a limitation about how much meta programming we can do? Or say, I work on a clinical trial data. We're producing tables, so we can have everything done in one and keep on calling that, or is just have only limitation of how many times we can do that. The arguments, sake of arguments.
Not, I mean, not really. You do run into, if you're doing like metaprogramming on metaprogramming, it
Yes.
gets hard. Like
Okay.
keeping track of where you are gets really tricky. Um, there are probably cases that just you can't write it. You would have to mix base and Erlang because Erlang would be fighting itself, or like I can't think of an example right now, but I could imagine that kind of thing happening. Um, but for the most part, there isn't really a limit. It's just like probably don't go too crazy. Like a lot of
Yeah,
times,
I didn't
like
even start yet, but I was thinking
yeah,
of how much the push limit, we can limit to certain extent, then, have that stop there and then call it on top of it, calling within each other. So I was just thinking widely of it. And the reason
I
for it
think
is
yeah,
there are some macros, the company based macros, where you just call once and it does entire work for us and get back us the result of it. Just say one name of the table, that's it, and it gives me the mean, median, mode, and everything in a right formatted way. So I was just thinking whether we can do something very similar to that.
I think a lot of the time you really just want a function and you don't need to do crazy metaprogramming things. Um, if you want to do tidy evaluation style where you allow people to pass in the bare column names, things like that. Yeah, that's pretty common to do, and that is kind of the minimum level of metaprogramming that we'll see in the next chapter or two.
Mhm.
Um, but past that, I have definitely had times where I'm like, oh, I'm doing this fancy thing, and I'm like, oh, that should just be a function. Like I should just do that normally instead of trying to do this fancy thing. But if you're trying to um like write code that uh helps to generate code or that uh well like I think some of the like scales and things like that for ggplot, you're doing some weird metaprogramming stuff in there, but you don't notice it because it's returning a function under the hood. So like we'll see examples as we go, and I'm a little bit of a hypocrite because I definitely have some cases where I actually have quite a few cases where I use weird metaprogramming things, but it's to do weird things. So um, I think that's okay. Uh, like I have this package has all kinds of uh, metaprogramming under the hood because it's a combination of like it's shiny and uh, like auto-generating functions and all kinds of stuff under there. So that has some weirdness in it for sure.
Yeah.
But it's interesting to kind of it's good to step back. Like there's a whole section in the Rlang docs talking about, do you actually need this? Can you just use ... and pass it on to the next function? Several years ago, Jenny Bryan had a talk at what was our studio conf at the time, basically about I can't remember what it was called, but it was like, you probably don't need tidy evaluation or something like that. It was all about like the ways that you can avoid it and make your coding simpler. So, which I will try to find that talk and put it into the chat
Yeah.
or into Slack.
I
It's good.
I was trying to find that talk and I didn't success, but I saw it and it's really good. I watched it.
Gotta go expanding. Really gotta see.
Actually, I think this is the one I was thinking of. Now this one, like, it's kind of out of date, probably. But the general theme still holds. It's 6 years old now, but almost 7 actually. All right. So cool. We will meet again in 3 weeks, on January 6th. And continue this. And I look forward to seeing you all then.
Same here. See y'all.
Bye. Oh,